All right, in this problem, we're trying to figure out the number of text messages sent by three people, Latoya, Pablo, and Trey, I believe. And then it talks a little bit about those things. So what I would do first is I would define what the variables are. So X is going to be the number sent by Latoya. And Y is going to be the number sent by Pablo. And Z is going to be the number sent by Trey. And then I know a couple things. Like I know there's a total of 135. So I know if I add all these together, I should get 135. And it says Trey has sent 3 times as many messages as Latoya. So Trey, who is Z, has sent 3 times as many as Latoya. So Trey, 3 times Latoya, who is X. And then the final one says Latoya has sent 10 fewer than Pablo. So Latoya, 10 fewer than Pablo, so Latoya is X, and that's 10 fewer than Pablo. So if we subtract 10 from Pablo, we'll make them balance out. So here is our equation. Now there's lots of ways to do this, to solve it. The easiest way I see is since they all have an X or a Y and a Z, what I would probably do is I would solve this one for Y and make it X plus 10. Benefit being is now I can plug X plus 10 in for Y, and I could plug 3X in for Z. So I would end up with X plus 10 plus 3X equals 135. And so now this all my variables go away to 1, and I can just solve for X. So I get 5X, because I have 1, 2, and then 3, plus 10 equals 135. So 5X equals 125. So dividing by 5, X equals 25. So 25 is Latoya, so she sent 25 texts. And then I could just plug X into the other one. So for example, Z equals 3X. So Z is going to equal 3 times 25, which is 75. And so that's Trey, so he sent 75 texts. And then I can go and I can do Pablo, because I know Y equals X plus 10. So that's 25 plus 10, so that's 35. So most of these work the same way, where you have to set up 3 equations, and then you can usually substitute and get them into one equation that you can solve for one, and then just plug it into the others.